Hello everyone, today we're going to have a look at our last three PIC microcontrollers, which are the 18F series PICs. So let's copy the previous project. Copy. Now let's name it according to our first device, which is 18F2220. Okay, I'm happy with the paths. I'm going to copy it. Now let's right click and let's set it as a main project. Let's go to settings for the project, and now all of those three PICs, they will belong to our advanced 8-bit microcontroller units. Let's select the device 18F2220. Lovely. I'm using the same PIC kit 4, same compiler. I click apply. Okay, right, so that's where we are. Now let's go to source file, rename this main file. Okay, just gonna select all the I have to change 2220 and click OK. Lovely. Now let's double click to open it. So this is the program that we've got from 16F628A. So we know that we need to change the configuration bits. I'm gonna highlight this all, click delete. Now go to production, set configuration bits. I'm going to just expand this a little bit more. Advanced series PIC got much more configuration bits to set, but please don't be afraid. It's a little bit scary at the beginning, but later on we're going to talk about this and it's going to be absolutely fine. For now, let's select the internal oscillator. That will give us the functions, digital functions on port A6 and A7. Now the rest of it, what we don't need, we're just gonna switch it off as always. Whatever we don't want, we're just gonna switch it off. So we're just gonna go ahead and switch everything off. Okay, like so. Everything is off. I'm gonna generate the source code, copy, including the compiler header. Okay, copy. Now let's go back to our project. Let me just bring this a little bit down, maybe like that. Okay, click above the main section and paste. Okay, so this is our configuration for 18F2220. Now we're happy with this. So let's go ahead and let's see if we can build a program for PIC 18F2220 using the command section from 16F628A. Just build for now. Okay. So what we see is a build successful. What does that tell us is that the program written for 16F series PIC more likely will work on 18F series PICs or 18 series PICs, but this more likely be not backwards compatible, and we're gonna see in a moment. It's always best to write the program for the device and know what is happening if we want to upgrade the device. Downgrading is a little bit worse case, bad case scenario, but yeah, so that's what we have, and we're gonna try to compare it to our data sheets. So let me just bring this a little bit like that. Data sheet for 18F2220, lovely. So let's make this a little bit bigger. Okay, now let's go to the pin diagrams. Okay, let me make it a little bit bigger. What we have here, what we see is we've got maybe like that. We've got port A, we've got port B on the other side, and we got port C as well. Okay. So in this today's video, we're gonna use the port C. We're gonna be configuring the port C in our PIC 18F2220. So okay, let's zoom this out and let's go for the configuration of the input-output ports. Okay, so this section starts with the port A. Let's go down to the port C section. Okay. This is it, or this is our port C section. So we've got all the information about the port, example of the assembly language code. Now let's go down to the table that is telling us of the registers. What we see here, the registers associated with port C. We've got port, we've got LAT, we've got TRIS. A LAT is kind of a new register that we're going to be using, and we're going to be talking about this a little bit more in the later on videos. But for now, what we need to know that we need to use port and we need to use LAT. So the difference is when we write information, when we want information to change on the pin, we write into LAT register. When we read in from the pins, when we read the state, we read from ports. Okay, sometimes you can see the programs that read and write to LAT registers. This is not wrong, but there are some rules which are good to follow. But we'll have a look at this in our later videos. But for now, let's change this code. Now, let me just make this a little bit smaller so we can see our data sheet. Okay, so what we're interested in is TRIS C. In hex, we know that this is all output. Okay, so let's delete all this, because now we're going to be writing to our new register, which is our LAT register. So the first thing, let's write to the whole port LAT, to the whole latch, and we're going to say LAT C is equal to 0 hexadecimal. We want all of them outputs to be high, so we say FF, and that sets them all to the high state, which when we probe, we should have all of the pins on. Okay, so let's try to build it for a moment. Okay, and it's successful. So the build is successful. Now let's go back to our pin diagram. Okay, this is our pin diagram. Let's make it a little bit bigger. Right, maybe a little bit more. Okay, like so. Let's move this to this side. And let's have a look at our connections. So we've got our board as usually. We've got the power supply, which I'm going to switch on at the moment, just to not forget. Okay, we've got our LED, we've got the resistor, and we've got the jumper wire, which we'll be using to probe the state on the pins. So now on our PIC programmer, we've got the pins that we need to connect, so we're going to do that in a moment. And now the main part, most importantly, our PIC. So let's just put it in here, maybe like that. I'm just going to press it in firmly. Okay, let me see if I can zoom in for you to see. Yes, 18F 2220, lovely. Okay, now our connections, we have to follow the datasheet, what we see. So we've got MCLR, we've got programming data and programming clock there. So these are the pins that we have to connect with our PIC kit. If you want to know more about this connections, then you can see my previous videos where we explain how to connect it based on the other PICs, but the idea is actually the same, to decode the datasheet and know which pins are which in our or your PIC kit programmer. You can have a PIC kit 3, but this connection is going to be the same. Okay, I'm just going to move it aside. What we have, MCLR, programming data is blue, and we've got the clock in yellow. So that's the connections to the PIC programmer. Now also what we have in here, we've got the VSS and VSS here. So these are two negative power supplies that we have to connect to PIC, and the positive we've got here. So 1, 2, 3, 4, 5, 6, 7 pin from the bottom, or 8 from the top, we've got to connect to the negative power supply. So let me just take it like that. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And let's connect this one to the negative. Yes. 1, 2, 3, 4, 5, 6, 7, and 8. Lovely, just in case. Now on the other side, we've got 1, 2, 3, 4, fifth one to the negative. Okay, 1, 2, 3, 4, fifth one. Okay, let's connect this one to the negative as well, like so. Okay, negative, and the positive, it's going to be just above this one, above the negative, VDD. Okay, so the positive, I'm just going to place it here and push it down. Lovely. 1, 2, 3, 4, 5. Okay, lovely. Now let me just zoom it in a little bit more. Okay, great, that's zoomed in. Now we've got the programmer connected to the PIC device. Let me just bring this down. Okay, now let's program the PIC. So I'm going to build and program. Program is successful. Programming verifying complete. So let's go to our device and probe all the pins and see if it was really successful. So what we're going to be probing is starting from the fourth one, which is the RC0. 1, 2, 3, 4, 5, 6, and 7. So these are the pins that we're going to be checking. So 1, 2, 3, 4, 1, 2, 3, 4, lower nibble and upper nibble. You can say that are there. So I'm just going to grab this jumper wire and just grab it a bit better like that. Okay, 1, 2, 3, 4, fourth one, this is on. Yes, 2, 3, 4, and a 4 from the other side. 1, 2, 3, 4. Lovely. We've got them all set to high state. Now we know what we're interested in. 4 pins on this side, 4 pins on the other side. Let's bring this down a little bit. Let's change it, maybe now. So let's do it in a binary so you can visualize it a little bit more. So starting from the upper nibble, let's say that we're gonna have 0, 1, 1, and 0, and the lower nibble is gonna be 1, 0, 0, 1. Okay, so let's build and program this as well as a verification. Okay, lovely. Let's go and let's probe it. So this side is the lower nibble, so this is RC0. RC0 is 1, so it should be on. Yes, it's on. Now we should have 2 zeros, 0, 0, and 1. 1. Now on the other side we should have 0, 0. Now we should have 1, 1, and 0. 1, 1, and 0. Okay, so the programming is successful. Now what we need to or we can check now as well, let's program all the pins now in a hex to zeros, so all of them are low, all of them are switched off. Let's build and program, and we've got it successful. So let's just quickly probe it, make sure that all of them are off. Let's select few pins, off, 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 off. Yeah. Now what we're going to do is we're going to leave this like so, but then in here let's target the pins separately. So we say LAT C bits, okay, and then I press the dot. What's happening is compiler is helping me with the instruction. So which LAT would I like to write to? So I'll be writing to, let's say, LAT C2, and I'm going to set this high to 1. Now the same thing, I'm going to say LAT C bits dot, and I'm going to select LAT C5 as well, and I'm going to set this one to high. Okay, now let's build and program. Great, so that is successful. Let's probe it. Let's see what's happening. So 1, 2, 3, 4, 0, RC1 0. Now we've got RC2, which is LAT C2. This one should be high. Is high. Next one 0, so that's LAT 4. Now this is LAT 5. Okay. There we go. LAT C5. Zero, 1, 2, 3, 4, 5. Okay. There. 0 and 0. Lovely. So as you see, this way we're affecting the single bits individually, not as a whole port, but as a single bits individually, which is very useful for us when we be programming in the next videos, in the next sessions. Okay, so this is really it for this PIC. Now let's have a look quickly on the next ones. So let me just make this one bigger. Okay, now our next PIC in line, let me just copy this. Copy. Our next PIC is 18F2520, and I'm gonna copy that. Okay, lovely. Let's set 18F2520 as our main project. Okay, now in here let's change the device. 18F25, come on, 2520. Yes, same PIC kit, same compiler. Yes, and then okay, right, so we've got it here. Now I'm just going to double click on it and source file. Now rename so we know. Okay, 2520. Great. Let's double click again and open it up. We've got the identical program. Yes. Okay, what's the difference is the configuration bits. So let's have a look at the configuration bits for 18F2520. First, let's delete this. Okay, so I'm gonna go to production configuration bits. I'm gonna open this up again. Come on. Okay, so again, quite a lot of those bits, but don't worry, we're gonna just talk about them later on in the other lessons. For now, what we need to do is select our internal oscillator. So internal oscillator block, port function, RA6, RA7. We're using a port C, so really it doesn't matter whether you select this oscillator or that one, but let's select this one. Okay, and the rest of it I'm just going to switch it off quickly. Okay, so we've got this switched off. I'm just going to generate the source code. Let's copy it, including the compiler header. Okay, copy. I'm going to bring this slightly lower there. Click above the main and paste. Configuration bits for 18F2520. Okay, I'm going to leave this as so. Let's try to build a program. Okay, build successful. As we said before, the program written for any PIC 18F series will be more likely okay for the next PIC, but there is a major difference in a PIC's memory, but we're going to talk about this later on for the program memory. But the small programs, you can use them for any 18F series PICs. So okay, let's go ahead to our PIC board and let's change the device. Okay, so I'm just gonna gently remove this PIC. Okay, now let's bring our next guest, 18F to 18520. Yes, can I show it to you? And there we go, just faintly there. Okay, so maybe first let's go to a data sheet for that device. There we go, 2520, few devices on this. So let's go down to the pin diagram. Okay, let's make it a little bit bigger. Okay, what we see here is the ports very similar. if not the same, for both of the PICs. So this is our again our RC port here and our power supply here and there, so they are in the same places. We're gonna just replace the device like for like. So if I place my PIC in here, there, like so, up, yep. So what we have is we've got the MCLR there where it should be, we've got the programming data and clock there where it should be as well. So power supply there as well. I'm just gonna go ahead and program this PIC. Let's click in here, build and program. Okay, so we got the program successful. Now let's go and let's probe the pins. Let's take this. Okay, now the layout is the same, so we go and let me just move this maybe like that. Okay, so we go and count in the fourth pin, 1 2 3 4, so we should have 0, RC1 0, now RC2 says 1. Okay, now RC4 RC3 sorry, 0, RC4 0, RC5 on, and the rest of them off. So the program works perfectly the same for both of the PICs, apart from the pin configuration. Let's go and delete, or actually let's leave this. Now close this, collapse this. Okay, our last PIC now we're gonna be talking about is PIC. Let's just copy this. It's PIC 18F 4520. Okay, just gonna copy. Now let's make 4520 our main project. Okay, let's in here change the device to our 4520. Lovely. And I'm using the same PIC 4, same compiler, apply, and OK. Now let's open this up to the source file, rename the main file so we know 18F4520. Okay, main. Double click to open it up. Right, so I'm gonna make it bigger for a moment. We've got the program copied from 2520 to 4520. We know we have to change the configuration bits, so I'm just gonna delete this. Now let's go to production, set configuration bits. Okay, make this bigger. Nope, I'm just gonna close this. Come on, just go there. Okay, right, so these are the configuration bits for 4520. Now we're gonna select the internal oscillator again, 67, and the rest of it we don't need, so I'm gonna switch it off quickly. Okay, everything's off. Let's generate the source code and copy, starting from the include file, configuration bits, copy. Let's bring this slightly down, lower. Great. Click above the main and paste. So we've got our configuration bits in the right file. Now let's make a little space there. Okay, let's build the program. Okay, what we see, the program is building perfectly the same as we said before. 99% the program is going to be working in all of the PICs 18 series, depending on the program memory needs, obviously. Okay, so now let's make this one a little bit smaller like that. Let's go to the data sheet. So the data sheet is the same one as for 2520, but if we go slightly lower, we see our PIC 18F4520. Why we selected all those PICs, we're gonna talk about again throughout the videos, but if you have any questions, please ask them now in the comments, so I will try to explain before. Now what we can see, we got much more many more pins, much more possibilities. So for now what we are interested is we're gonna have our port C in here. We got RC0, 1, 2, 3. Now we have to be careful because now this is a port D now. So RC4, 5, 5, 4, 5. Sorry, RC4, RC5, 6 and 7. Okay, so that's how it is. Now this is the connections, power supply connections to the PIC as well. So what we see here, we've got the double negative and we got double positive, and that's how we're gonna connect it now. So let's go to our board. Let's remove this device. Okay, let's remove those power supply pins. Oh, flick. Okay, this one as well. Come on, we're gonna be needed in a moment. Right. Okay, so this is our PIC. Now let's have a look. 4520. Now I'm gonna place it somehow in here like that. Okay, slowly. Okay, now why have I placed it like that? Because as we can notice on our datasheet, the MCLR and programming data and clock pins are exactly the same as on our previous ones, so we can use this to our advantage. Okay, now let's go and connect it to the negative rail. So what we see is 12 pin from the top is the VSS, the negative one. Let's calculate, let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's that one. It's gonna go here and it's gonna go there. No, let's go there. Okay, so that's negative. Just above it there is a positive connection, so let's go and connect this to the VDD. So that's in here and in there. Okay, that's positive. Now on the other side we've got let's maybe count from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10th one from the top is VSS. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, so let's connect it to the negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, like that. Lovely. And the one above is going to be connected to the negative. Let me just try to find another jumper wire. This one to the positive. Okay, there we go. So that's our connection. Now let's go to the program. Let me bring this down. Up too much. Okay, and let's go ahead and build and program it straight to the PIC. Okay, lovely. We've got programming verifying complete. Let's go and probe our PIC. Maybe let's bring the datasheet up. So what I'm interested in seeing is RC0, 1, 2, 3. So 1, 2, 3, 4, 5, 6, 1 from the top. Okay, 1, 2, 3, 4, 5, 6. So RC0 should be 0, RC1 0, RC2 1. Yep, RC3 0. Now RC4 is just the same line, so 0, RC5 1, and 6, 7, 0 as we've expected. Lovely. So this is it. This is how we program those PICs, the registers, the LAT, the port, the TRIS register. This is what they do. Going forward, I'm gonna be using this PIC 18F2220. Yes, so I'm gonna be using this one for main projects. We're gonna have a look when we switch into the other ones. Thank you very much, guys. I hope to see you in the next videos. Thank you, and bye.